Today we're going to talk about more specifically sigma notation, and what the sigma means is repeated addition. So if we look at the example I have here, we're going to go from starting k at 1 to 10, and then the 3k plus 4, that's the formula represented by either an arithmetic or geometric sequence. In this case, without an exponent, it's arithmetic. And then you would start plugging in values of k. So you'd plug in 1, then you'd plug in 2, then you'd plug in 3 until you got to 10, and then you add them all together. So the first example says write each series in expanded form. So the first thing we're going to do is say 5. We're going to start with 1, plug in 1. 5, plug in 2. 5, plug in 3. And 5, plug in 4. This is expanded form because it's got all the plus signs in it. And then now if we just simplify that, 5 plus 10 plus 15 plus 20, and then we add it all together, and our sum would be 50. So this is, again, the expanded form, plugging it in and then showing the simplification. Now here, this is an infinite one because it goes from 1 to infinity. So you would start by doing 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus, and then you would just show that it keeps going for expanded form. Okay, now we're going to write using sigma notation. So the first thing that we're going to write our sigma down, and then we're going to figure out what's next. So big sigma there, and we're looking at this particular series. Looks like I'm adding 4. So this is arithmetic. And then now we're going to come down here. So first of all, we're going to find the formula. Okay, and when we find the formula, we're going to use a sub n equals a sub 1 plus n minus 1 times the common difference. So plugging in again, a sub n, a sub 1, the first term is 3. I'm leaving in the n minus 1, and the common difference is 4. So then we simplify 3 plus 4n minus 4, and our formula, a sub n, is 4n minus 1. So that means, opposite the sigma on the right hand side, I put 4n minus 1. Next, I need to find the number of terms. So this one, we go back, a sub n, a sub 1 times n minus 1 d. The last term listed there is 31. The first term is a 3. I'm putting in the n minus 1, and that's a 4. Now all we have to do is simplify. And there's a plus in there. Okay, so if I subtract the 3, I get 28 equals 4n minus 4. I get 32 equals 4n. And so my n is 8. So that means the top of my sigma is an 8. And now you just need to find a sub 1. So a sub 1 equals, a sub n equals 4n minus 1, and then a sub 1 is 4 times n minus 1, which is a 3. And the reason we do that is we have to know where to start the sigma. And so we are going to start the sigma at n equals 1. Because when I plug in a 1, then it's going to give me a 3. This next one is infinite geometric. So when we do it, our sigma, big old sigma there, and we know that our first term is 3 times our common ratio. It looks like we're multiplying by -4, and we're going to raise that to the n minus 1. And then we are going to start at n equals 1 and go to positive infinity. So remember, the first term goes in parentheses, the common ratio is the base of the exponent, followed by n minus 1. And then so for your assignment, you're going to see some writing the sigmas and then some review of what we did last week.